Does anyone recognize this?
Telegraph keyboard.
It's the first synthesizer. It's the first keyboard synthesizer, at least. It was built somewhere around 1860 by Elisha Gray, who was actually the inventor of the telephone. But Alexander Graham Bell beat him to the patent office by 1 hour, and years later was awarded the patent for the phone. So Elisha Gray invented the synthesizer, and it used the telegraph wires. In fact, he started the company known as Western Electric, the primary provider of telegraph facilities in the 19th century. So that's what that is. And it communicated, its output was actually via telegraph over the telegraph lines. I'm going to give a little history of, actually not much of a history, of 2 or 3 very early instruments. And then we can discuss my favorite topic, which happens to be controllers. How do we talk to the machines? So I'll show you a variety of controllers in a minute over the years. I want anyone that has a question to interrupt, and we'll digress and talk about anything you'd like to talk about. I don't know what your backgrounds are, whether you're composers or synth freaks or instrumentalists, but I suppose there's absolutely everything here. So, but anything you'd like to discuss within my realm of possibilities is fine. Now, can everyone understand my English? Is that it?
Sure.
We're all English first. We won't need a translator, at least for a while. Okay, good. Well, I've talked about the singing telegraph, as it was known as. Next is a very important instrument that was built right around the turn of the century. It's called a telharmonium, and that was designed and built by Thaddeus Cahill. I just have one little picture of it here. Here's this one. Yeah, actually there are 2 little pictures. This is the innards on the left, and these are 2 guys playing the main keyboard. It actually consisted of several keyboards. It could play, the latest version was actually tuned to 36 notes per octave, and it spanned a 7-octave range, going from 40 to 4,000 cycles. In fact, part of its demise was the fact that it was very difficult to play, and composers and performers didn't want to learn a new keyboard just so they could play what many years later turned out to be a just tuned, or a very close approximation to just tuning that was also used by Harry Partch, a composer from mid-20th century. Sorry, my voice is so bad. But the telharmonium weighed 200 tons. 200 tons. Occupied, it was moved from Massachusetts to New York City and installed in New York, and took 30 freight cars to move it. It was a huge train. It was first installed in about 1906. Later it was refined and built to larger proportions. And it was actually operational till about 1920. It used the phone lines for distribution. In those days there was no amplification, but his thought was that we could have music in every house coming over the phone lines. And there was about an ampere of power delivered to each receiver because it had to drive the speakers directly. No amplification. There were 3 versions built. The last one finished in about 1911. And it was used even during the course of the war and abandoned in 1916. The instrument, as huge as it was totally disappeared around 1950. Nobody knows what happened to these 200 tons of 145 dynamos, which is how the pitches were generated, sort of like a Hammond organ, but a much earlier version, and huge things about this big. It generated all the power required to drive the phone lines and the hundreds of subscribers that there were. But it suffered from a lot of problems, and when the amplification invented by DeForest came along, that signaled the end of the teleharmonium. His brother, I forget his name, but he in 1950 had the final teleharmonium, but he couldn't find a buyer. No museums wanted it, no individuals wanted it, obviously, and it's all gone now. Next. Oh, this is a known Martineau. And this is a very skilled player to the left. And Monique, who's sitting in the back row here, to the right. And this is invented by Martineau, and it's an interesting instrument. The left hand here is controlling a ring, which could be, I think, put on the right hand and allowed to play. And it's a polyphonic instrument, of course. And the left hand chose the speakers, and there was a foot pedal. Their speakers were all very non-linear. One of them had strings across it. Another one was a bit like a cymbal. It was a metal speaker, so on. One of them purported to be a linear speaker, but it was definitely not. And the foot pedal consisted of sand. And the harder you press the sand, the louder the sound would get. And the sand was from a particular beach in France, of course. And it required replacing periodically by a conductive sand. So it was interesting that it was the first foot pedal, and it worked by some rather crude mechanism. But it was an amazing instrument. And I think it's still taught today in Paris. There are occasional new ones built. There were 7 of them built in the 60s that I know of. And maybe it's regarded as obsolete now, but it was still going strong at that time. Oh, this is theremin, another instrument of the 30s. It was. This is played. You're all familiar with the theremin, I'll bet. The right hand governs the pitch. This is actually Leon Theremin playing it in his youth. And get some notes on this. Oh, I wanted to show you this is an amazing instrument called what did he call it? The Salmar construction. His name is Sal Martriano. It consists of, I think, 291 touch-controlled switches. The switches were part of the logic of the machine and could be overridden by touch. So he had all this program. This thing in the back, up above his head, is a huge patch bay. It has literally hundreds of wires that were interconnected. It had to be completely torn down between performances, so, and the whole instrument weighed 400 pounds. And it drove 24 speakers, which were hung, I suppose, with some logic, but to me they were random. They were hung around the audience at various heights, all kinds of places. And it was a fascinating instrument, but it was very unique. There was only one build, and Sal traveled around with it, playing in this country and in Europe for several years and several gigs. And he passed away about 3 or 4 years ago, maybe more. But the instrument is certainly no longer. Getting into, I remember another one. Well, Bob Moog built a multiple touch-sensitive keyboard, which I regarded as pretty interesting. And in fact, I'm working on a similar one myself now. He never got it together because he made it so that each key was a microcomputer. And that took too much technology at that time, and even now it would be a formidable amount of technology for one keyboard to have a microcomputer mounted on each key. And each key could sense velocity and lateral as well as vertical sensitivity, and of course pressure and aftertouch and all those good things. But it was fabulously expensive and quite complicated, and never made it. And I don't have a picture of that. But I do have a picture of that's another picture of you can see a couple of the suspended speaker systems with the Martriano construction here. This had to be completely disassembled for transport, and it took about half a day to reassemble it at a new location. So he didn't travel a whole lot with it.
Excuse me, how do you spell the name of the instrument?
It's the Salmar, S-A-L-M-A-R, construction was the name of it, and it was designed by Sal Martriano. He's Italian, spell it as you would in Italian. Just to say, this is a continuum fingerboard. While we're on the subject of keyboards, I thought I'd show you some other approaches to multi-dimensional keyboards. This one does not have discrete keys, but he refers to it as a keyboard. The elements it's a row of rods, and he uses Hall effect sensors to sense the displacement of the rods. So that as you move your fingers up and down, you're moving along a rod, but moving laterally, you're hitting different rods. So he gets X and Y, Y being the discrete dimension and X being the continuous dimension. And they're all covered by fabric so that you can move smoothly along. It's marketed even now. In fact, it's
a ribbon control.
Pardon?
It's a ribbon control.
No, it's more than ribbon control. It's like a large number of ribbons because it's a two-dimensional controller. The ribbon is confined to one dimension. The ribbon, for those that don't know this one, is a controller used in, I think Moog might have invented it, in fact, used in his very early keyboards, and just played like that. He didn't invent it because it was the same as the What's the own mark? No controller.
There's a multi-dimensional ribbon controller.
Yeah, this is more or less a multi-dimensional controller. It's pretty high tech, and it uses Hall effect sensors on each of these rods that can be displaced. And it's not clear from this picture how it works. But they're marketed now, and they're being sold and enjoying some measure of popularity. It's a MIDI controller.
So it's MIDI protocol.
Yes, it's a MIDI output. And yeah, it's a pretty good controller, I think. It's for what it is. It's not a keyboard. This is another keyboard. A lot of these things have been invented over the past few years. They're probably being invented even now. There are multiple ways of people would like to play the keyboard with the same pattern, but in different keys. And so the game here is to move your hands around, play the same patterns. You can always get this to be a triad, major triad. No matter where you play it, it'll be the same shape as your hands. The tonality varying according to where you are. I don't know how this one works exactly, but I say there've been a lot of them built. Oh, this is another. We think of this as a keyboard, but it's played by metallic strips that are placed on the thumbs and forefingers. And rotating it, you can play a variety of keys, but you can play it with the same pattern used for various pitches. So it's kind of a complicated thing. He was talking about putting it into production, and in fact several were made. But I think that he didn't find it sufficiently interesting. I found it interesting. Oh, this is the last keyboard that I'm going to show you. This was built by a guy named Eimeyer. He built several interesting instruments. This being the keyboard, which I've seen recently. There have been a number of dance keyboards made for kids that manage to dance on these things. He cautioned the user to utilize the buddy system when they were attempting octave intervals. And from keyboards we branch into mallet played keyboards, essentially. This is the Mallet Cat. This was designed by a guy in Boston, whose name, what's his name? Mario DiCusi. And it's a MIDI interface, and it's responsive to more than just the standard mallet responses, but not much more. And it uses the keys are made of a conductive material, and the harder you strike them, the louder they become. And I developed, there's another, yeah, this is a very refined version of a keyboard instrument, but it only did mallet sounds. It's called the Xylosin, and it was made in Britain. And I don't know too much about it, other than the fact that it's a mallet instrument that was electronified. It had pickups on each key. And then I built an instrument known as the Mallet Cat. It was built because I had several people working with me that were mallet players, and I decided to build them a controller. And this is the result. And this is called the mallet, the Marimba Lumina. The initial version of this used optical apparatus for sensing the position and location of the duo, but it's responsive to the position of the mallet along the key, and it's it can tell the difference between the mallets. So that's why the colored mallets there is. The yellow one can be a different MIDI output operating on a different channel than the green one, the red one, and so on. It can measure the velocity of a mallet approaching it. It works on a principle that's kind of interesting. It's complicated, but it's worth it. Each of these keys is a radio transmitter, and it transmits a signal very briefly and in rapid sequence to each of the to determine which of the mallets it's seeing. And so it transmits a signal at various frequencies. And the mallets are totally passive devices, but they have in them a tuned circuit which responds to the antenna if it's within the proximity of the antenna. And the tuned circuit resonates, and then we shut off the transmitter immediately afterwards, and the tuned circuit continues to resonate. The antennas are all turned into receivers, and they receive the signals from the mallets. And we can tell with amazing precision exactly where you are on the key, and exactly which key you're striking, and how fast you're striking it, because the mallets are sensed some distance, perhaps a centimeter or two above the keys, and the velocity can therefore be sensed, and the velocities can trigger all kinds of MIDI phenomena. There are some keys here that are static, so that a strike of a key can change a program or change the parameter articulation and so on. So it's a fairly high-tech instrument. It was actually, I sold this to a company, Near Field Systems, which are basically an antenna testing company. They build very large systems for measuring the output of an antenna within a very close precision, so that their antennas are large dishes, sometimes as much as 10 feet in diameter, that are used by the phone company and by the military and so on for very long distance transmission. But they base and they call themselves Near Field Systems, because they've come up with algorithms that can, with great precision, measure the long distance field of an antenna by looking at just by scanning the antenna and measuring every point on it. And they can do that with the precision. In fact, it's necessary to get sufficient precision in the measurements to about a thousandth to 2,000th of an inch. So they move this gadget around just 1,000th of an inch over a 10-foot span. So needless to say, the electronics in it is pretty complicated. So these guys are used to building extremely complicated electronics. The antenna, a typical one, would be built on a granite bed, because the granite is stable enough that they can make these precision measurements over a very large period. They failed to be a success in the marketplace because this attempted to be a commercial instrument, and the antenna measurement systems that they were designing were designed to mil-spec and cost upwards of $1 million each. So they put in the same kind of precision into building marimba luminas, and they would disassemble the boards and take them out to test laboratories and so on, and built them with great precision, but unfortunately lost a lot of money in terms of market. Turns out there's a very small market for this sort of controller anyway, because it plays on the skills of a mallet player. And a mallet player, as you all know, takes many years to perfect his instrument, and becomes very expert in the quality of the wood used on the keys and so on. And so this would be regarded as just sort of a practice instrument that he would never use in a concert situation, because it doesn't sound like a 1923 Dagon or something. It's just kind of
But you actually built some of those instruments.
yeah, there were quite a few built. There weren't enough. There are not enough skilled mallet players to account for a good market. But
Did Mark
everybody that
Goldstein-
was not a mallet player that approached it was intimidated by it because they couldn't handle 4 mallets. And so they watched in awe as people play it, but they couldn't buy it or experiment themselves because it was an instrument. So it's something I learned about instruments and controllers in general, is if you want to build a controller that's dependent or apparently dependent, it isn't really, but on a technique, and I provided 4 mallets, that takes years to learn, literally years, then you're not going to sell very many of them.
There are a few, I mean, for people who are very skilled percussionists who want to use that stuff, those skills to play electronic music, it's kind of one of the more popular options because, for one thing, the distance sensing allows you to reduce latency a lot by recalculating the velocity of the thing before they hit it. And so actually some of the more, there's quite a few high profile musicians who are using this thing, I mean, comparatively speaking.
Well, the number would be how many?
Well,
20?
yeah, I would say more like 5 or 10, but,
Yeah.
you know,
You're about right.
there's,
Mark Goldstein was
Good.
voted
Oh,
in
Mark
the pro.
Goldstein
Yes.
is one of the users.
but also, you know, Tortoise.
Tortoise,
um,
yeah.
Angels of Light, Resonance, and Lucas Ligeti.
Yeah, Ligeti's a good composer. And Mark, in fact, did the programming on this.
Yeah, he had been here. Well, I think at the time you were developing the system.
Oh, right. Huh. I didn't know he'd come here.
Yeah, he came here.
Yeah, Joel DeVell
It
and
is very.
Brian Rice were the other 2 mallet players in the company, and they both became very good at it. So that's the story of the marimba Luna. And what we have now. Do you want me to continue with controllers and so on? Anybody interested? Shall we digress and do something else? Okay, more on controllers. This is a string controller that I built for Ezra's mom. Here it comes. And this, called Essence of Cello, has independent pickups on each string, and is not an electronic instrument any more than the electric guitar is an electronic instrument. But it was used in concert, and perhaps still is. She still plays it. And it's my only attempt at building a controller with strings. That's why it's here. These are some of the old modules that were used to extract features from the cello. The left-hand module is an envelope follower. It could detect pulses and detect transients, as well as levels from the individual strings. And the frequency detector could detect pitches and respond to them very fast. And these are more string controllers built by others. The Zeta people went on to build quite a few bass and viola, and recently the cello also. And that's a synthax. It consists of keys on the, I believe this one has keys on the left and strings for the right hand. And also alternative keys keep pointing to this, but I realize I should be pointing up there. Do you have a pointer? I don't know. But the keys are on the right-hand side there, and the strumming is actually played with strings, with pickups, and then the left hand is playing a lot of switches. And this is another, this is a syntax, the previous one was something else. This one has, again, strings for the right hand and strings for the left hand as well. And it's a complete MIDI instrument. And there's one of these bars. This is the longest string, or one of the longest string instruments. I've seen one longer than that. That's Joel on the right, playing a marimba lumina, and he plays in concert with the guy on the left, whose name I forget now. It's a 20-foot, Paul Dresser, and it's 20-foot long strings. There are, I think, 4 of them. Yeah, it's called the quadrophone. And he plays it in an incredible variety of techniques, and so it's quite an interesting instrument to listen to. It's fabricated so that it can be folded up and transported on a moment's notice.
What is the frequency range?
It goes very low.
Yeah?
I don't know. Do you know, Reggie? I would guess 30 years, 30 or 40 something. It's quite a versatile instrument. He rolls ball bearings along between the strings, and that gets quite a sound, and it retunes the strings as he's playing them at the same time. They do a lot of amusing things with it. He built another instrument. I don't know if I have a picture of it here. This is the other instrument I was going to talk about. It's a very large, high instrument. It takes about 4 people to play it. They're climbing on it to reach the strings at the top. And there's a pedal in it, just like that. It's a very strange instrument. But I like it. It's the world's largest controller. And this is an instrument whose ORB stands for Optical Ranging for the Blind. And I was involved in the blind school and built the orb for blind people to navigate with.
There's no signal output here. You can see a picture.
If I push this button, this is the only, or I built several prototypes like this, and then I failed to make it into the instrument that it was meant to be made into, which is the size of a pack of cigarettes or so. So this is a pretty large instrument, and it works. This is one of the this is a very old instrument. This is one of the first LEDs built, and it was given to me by RCA. They gave me 5 of them. They were worth $500 each, just the LED, which is a very inefficient device in those days. Now they're quite efficient. But it was focused by a Fresnel lens, and it has a mechanical gadget that's going like this, around 60 cycles per second. And so it's refocusing the whole mechanism onto the photodetectors and the LED. And I bring it here because it was used by John Cage in a concert. I set it up so that you put your hand in front of it, you were changing the pitches of an oscillator. He enjoyed it, and it was part of one of his pieces, in fact. So that was potentially a controller. I also used it in another musical application. I had it pointing straight up, and then I had a mirror turning like a lighthouse. And so the mirror this beam was scanning its environment, and placed in the middle of a gallery, it would respond to anybody standing around it. It would generate a note according to where they were standing, and the pitch of which was dependent on how far from the center they were standing. So you could vary the timing according to where you stand around it, and the pitch depending on how close you were to it. So as people shuffled around and we varied the speed of it to essentially you're playing a repetitive measure, and each person was responsible for a note. It was strange. But, and it was a gallery installation that went on for some time. Let's see, any other things worth mentioning? No. So I'm gonna show you some more controllers that I invented. The problem here was that MIDI came around, and for 3 or 4 years I was very excited by MIDI at first. Not enough to endorse it, but anticipating its use. So I built a system called the 700, which had not one, but about 5 MIDI inputs. I was thinking, well, everybody will be able to plug into it with their different controllers. But by 3 or 4 years of MIDI, there was nothing but keyboard controllers. Absolutely nothing else was built. So I built the first non-keyboard MIDI device, and it's somewhere in here. Oh, here it is. There were 3 of them, actually. There was a quad. I developed 4 controllers at the same time, and they were called Thunder, Lightning, Wind, and Rain, and they were my contribution to the environment. And these are pictures of summer. We had a performance group together. That's Mark Goldstein on the left, and that's me on the right, and that's Susan Radcliffe, who is an amazing wind developer in the center. She's playing wind, in fact. She developed a lot of ceramic wind instruments. And Thunder's to the left, that was marketed up until 1990 or so. And in fact, there are quite a few of them still around, and they're still played somewhere. That's Lightning on the left. That's played with 2 wands, in which we can isolate we can measure the distance of the wand from the instrument and the lateral position of the wand. And well, actually, this version didn't measure the distance from the instrument, but a later version does. So it's a 3-dimensional controller that's pretty responsive. It doesn't have much latency, and it can respond to where you are, and you can have zones of playing different instruments in different positions, and you can assign pitch to whatever you'd like, and you can have continuities and so on. It's a pretty elaborate language that was involved, so it does a lot of different things. It differentiates between the 2 wands. It can, and depending on what direction, you can move wands all 4 directions, and they're highly differentiated, so it knows exactly what you're trying to hit. I wish I had a video of a piece that we do periodically. It's called En Plein Vol. It's a piece in which the mallets are concealed, or the lightning rods, the lightning wands, are concealed in mallets. And it looks like the player, a percussionist, is playing mallets. And we wheel out mallet instruments. He has a marimba and some rototoms over here, some actual real rototoms. And up here we have some little miniature cymbals, and we have a big gong and a couple other things that he actually plays, or looks like he's playing. He's rehearsed the instrument enough that he can come within a half an inch of the instrument. So he plays the instrument with these lightning wands, and he's really playing a synthesizer. And he's playing a sampled synthesizer in which the samples are made from sometimes the very instruments that he's playing. So it's a little complicated. Now the thing comes it gets funny because we fool the audience into thinking that he's actually playing these instruments. But in the course of the piece, we steal the instruments. We start out by stealing just one temple block. Nanik has participated in the piece. She comes on as a thief and steals a temple block and conceals it, perhaps, and then sneaks off the stage. Well, meanwhile, the audience doesn't care too much about that, but some people in the audience think they may have seen the percussionist strike the thunder block. But there was no thunder block there because it was stolen, a temple block. Not thunder block. The piece continues with Nanik stealing, with a baby carriage, she steals the rest of the temple blocks while the player is distracted, otherwise he's playing his marimba. And one by one, she and another conspirator steal all of the player's instruments, leaving nothing but the player striking in air. Well, the audience by this time has figured something out, but you'd be surprised how many of the audience think that finally conclude that we're playing from a tape. The percussionist has learned how to accompany a tape with incredible precision because the sounds are all perfect. He's playing the marimba here, but it's really just a tape. Well, it's not really a tape, it's the lightning. And it can be played in that kind of way. We can have different instruments in different places and play them with very accurate pitch tuning and so on. So we wind up the piece en plavot by we've stolen all of the instruments, but finally the two players come and, actors I should say, come and steal the percussionist, who's meanwhile screaming, playing the instruments like mad, and being carried off the stage by the two participants. So it winds up with a blank stage, but the music still happening. And so much for lightning. Wind was never quite, well, it's actually completed, but it never really got quite completed. But it responded to the distance of fingers from the fingerboard by optical techniques. So as you raise your finger from the position that you see your fingers in, as you raise it, you will get you can get a continuous gradation in volume. So it's not just 4 switches for each hand, it's 4 detectors of where you are. So she could play it like a trumpet, if you like. And as you know, the valves of a trumpet are not discrete switches, they're continuous. And you change the timbre of the trumpet and the pitches depending on where you are. The instrument's capable of micro tuning of sorts, in that you can regard the 4 fingers, or 6 or any number that you want, as the vortices of a cube, that is the corners of a cube. In 3 dimensions, each finger would represent a corner of a 3-dimensional cube. Or I should say, each dimension is responsible for a corner. There's a movement between one axis and the other 3 axes. So that each corner can represent a pitch, and you can assign it in the software to a pitch. So if you're playing the binary of 3 down, then you'll be talking about that corner of a cube, and it'll respond with that pitch. And each of the corners of a cube will have a new pitch. Well, that's the basis of an interesting tuning system, because it can be, if you extend this concept of a cube to 4, and then 5, and then 6, we got a little crazy with the calculations. But you can have a 6-dimensional cube, and that would allow you to play 64 pitches, exactly. But then any perturbation you made by moving the finger above and around. You're now traveling around inside this 6-dimensional cube, and you can play any note in that cube. Well, it's remarkable what kind of tuning systems you can come up with in which the corners are discrete, carefully defined pitches, and all the intermediate spaces are up to grabs, depending on how you move your fingers. The mouthpiece, which you see her playing, is a transparent lucite pipe, and it analyzes the position of the tongue with lights that are sprayed into the mouth, in addition to analyzing the pressure, both positive and negative pressure. She can suck on it and be playing a totally different output. And the little antennas that you see, these little black things, which are hard to see, are actually infrared transmitters that are transmitting the whole thing to the receivers, which are positioned around the stage. So that where she plays it, there's also an accelerometer in there that can determine the position. So much like a cell phone nowadays, it responded to the position that she's playing. So she moves it around, or moves around the stage. We know where on the stage she's playing, and we can move the sound appropriately. So it was quite an interesting instrument, but that's where it wound up in a museum. And the thunder is, I don't know, I might have a more elaborate picture of the thunder. Yeah, that's the thunder. And this dates to, 1989? So, and it's a very elaborate instrument, a very elaborate software device which can configure these keys in numerous ways. The keys that are flagged with little feathers are sensitive to location. So as you move your hand, it will respond to location. The thunder is more or less a pitch trip, and can be used to, and the keys along the top are used in an editor which has many different menus, and you can do all kinds of things. And the two keys on the left and right are actually XY sensors, so they can, as you move your hand around. All of this is pretty common nowadays, but this was in the days before iPads and cell phones and so on.
Can I ask something?
Sure, please do.
Those sensors are like standard at that time? Or you
No,
have to
these,
use your-
we used a technique which I called capacitive sensors. And it involved membranes that were tightly stretched over a PC board. And then as you press the membrane, the capacity would increase.
So you have to build your own sensors? or
Pardon?
You have to build the sensors?
Yeah, it was completely, I designed the sensors and a little bit. In fact, now I still use a similar technique, but using capacitive sensors. Let's see. Oh. Yeah, this is another version of the thunder. This is a pretty interesting gadget. It's an actual drum head. It's actually manufactured by Remo, the manufacturer of 90% of the drum heads that you encounter. No matter what the drum head says on it, it will always be manufactured by Remo. This consists of a layer of about 9 layers. The first layer is an ultraviolet protector. The next layer is the paint. The next layer is this and that. The elastic returning layer. And then underneath, at some critical layer, is a mirror. So when you look at this, I should have brought one with me. When you look at the bottom of this, you will see your face. And if you're looking directly at it, and if you punch just the tiniest perturbation on the surface of this drum will create, if you punch right where your nose is, your nose will disappear. And that effect led me to designing this instrument. It has 24 photocells and 24 emitters distributed in a very peculiar but mathematically correct pattern. So that I could tell by analysis of this pattern, by the responses coming back from the photocells, precisely where your fingers were touching. It could sense multiple fingers, up to about 4 or 5, and it could sense them with a zone of confusion of just perhaps half a centimeter. And it could sense them with a precision of a couple millimeters. So I broke this area into 10,000 points, and you could sense each point discretely, and you could make continuous sensors or discrete. The graphics here, we applied thinking that we had to make a few less than 10,000 in order to make it playable and definable and so on. So this turned into 8, 9, 10, 11, 12, around 20 positions, and each one could respond to a totally different, each area there could produce a totally different sound, and we could tune up the whole drum head into any way that you could conceive of utilizing it. I chose to break it up into sounds, large sounds and small sounds. And I could touch a sound, and it would originate wherever I happened to touch it. And then I could move the sound around the drum. It could move in pitch or dynamics, and then when I lifted my finger, the sound would disappear. There was just an enormous number of possibilities. It was used once in concert. I brought it into the dressing room of a pianist named
Danilo Perez?
Yeah, Danilo Perez, and he was an excellent keyboard player, phenomenal keyboard, still is. And I had programmed it so that there was a piano in one direction and another piano in the other direction. So all he did was play piano notes across the drum and up and down. And by playing it rapidly, he could just do phenomenal things, but it always sounded like a piano because we had a MIDI piano hooked up to it. I brought it to him. He had never seen one before. I showed it to him in his dressing room between sets. I brought it in between sets while he was taking a break. And he looked at it and says, "Oh, I like this." And he brought it out to the audience. I didn't expect this, but he played it for the audience, having experimented with it for about 30 seconds. And he played this phenomenal piece for about 3 minutes on it, and it was just quite interesting what he could do with it, and having no experience with it whatsoever. So, but that was, as I say, I mentioned that because it was the only concert experience.
Was it recorded? Was it ever recorded?
No, it wasn't recorded. Some recordings were made later. The instrument was sold to EMU. I thought it was potentially a big time instrument, and could easily compete with the chord wave drum. And there was another similar instrument made at that time. EMU purchased it and proceeded to get it into production, but they decided to change it to instead of being a percussion instrument, we were just getting into the I guess it was the disco era, and so they wanted to make a disco controller. So they redid the visuals, the graphics, into what they thought was a good disco controller configuration, and they put a synthesizer into it, built into it, that was the Proteus Carnival. I don't know if you're familiar with that, but it's kind of a stupid one, but it responds well to percussion, and you can do strange things with it. But it was inappropriate for the instrument, and their approach was inappropriate, and their marketing department was inappropriate, and they tried to market it in the wrong way. They put over $1 million into developing an instrument from taking a wonderful percussion instrument and trying to change it to a DJ instrument. And they just never succeeded and finally gave it back to me. I could go into production now, but I'm always looking forward to new things. And that I regard as an interesting piece of history. But I still think it's potentially interesting. Anybody want to manufacture it, I'll give you the detail. But it had a sensitivity that was rather remarkable. You could hit it pretty hard, like this, what turned out to be 5 pounds of pressure, and you could touch it. You could put a feather on it, and it would respond to the weight of the feather. And it had a dynamic range that was 40 dB, which is a large amount for dynamic range. So it was a pretty interesting instrument. You can play it like this, or you can play it like this. It's a combination of...
This is the predecessor of Lemur, the controller.
The what?
Lemur.
Oh, no, you could compare it to the Lemur.
Yeah.
But the Lemur didn't have the resolution, certainly didn't have the dynamic range,
No.
and
I was
it
thinking about the
didn't
pressure
have,
control
the
here.
Lemur didn't even have velocity sensitivity. Well, this has enormous velocity sensitivity.
It has.
Oh, yeah,
Yeah, it has
Yeah,
pressure
right.
and the velocity
Yeah.
sensitive, but nothing else like that.
yeah, no, the Lemur was an interesting controller, but it suffered, and also the Lemur had a lot of latency. This thing was immediate. Well, the Lemur, I admired it when it came out, but it was not appropriate for control. It was appropriate as an input device to compete with the later to be announced iPhone. So, where else we have? Oh, this is mounted on I built this is just the crudest of prototypes, but it was mounted on a drum, about this big. It had a battery built into it, a synth was built into it, and you could take it to the beach and put it away. And there was an interesting thing that I learned about controllers, and that is that the sound emanated from the drum, exactly like the sound does from a drum. So, and the experience of striking this membrane and experiencing the sound immediately, right in your face, was one that kind of transcended the idea of a controller. You're playing here, sound is coming out of a speaker up there or something. So you felt as if you were playing it. And it was a real drum head, and it responded in just the ways you'd expect a drum head to respond, aside from the fact that it was very particular about the location where your fingers were. It changed the sound enormously. So it was a wonderful device for percussionists. The few that played it lapped it right up. A guy at EMU, who's David something, he developed all of the sounds for the DX7 that came along many years. No, came along earlier than this. DX7 sounds, and he was much admired for being able to direct the FM, which is not very obvious when you're programming FM sounds as to what you'll get. So he was good at that. But he was an enthusiastic supporter of this, and he's the reason that EMU purchased it. But then they put on... I was in charge of the development team at EMU, strangely enough. I would drive down there every week to meet with the development team. There was a representative from each of the divisions. There were about 8 of them. There was sales here, and circuit design, and PR, and so on and so on and so on, graphics. And they all took the instrument and tried to develop it to meet their needs without ever talking to the other group. And then when I came down, we had meetings in total silence. There was nobody that had anything to contribute about what the week's progress was. It's an incredible company. It's no wonder they But they were, it was not a very fun experience for me to be in charge of this development group that had nothing to say, nothing to do. Anyway, onward. What do we go next? There. Speaking of the lemur, the interesting thing about it was that they had around 3 algorithms, at least at the time I took this picture, and you could put a pod any place you wanted and move the pod. You could have bouncing balls around a billiard table that could, and the balls had momentum, and so it was kind of interesting. You could probably play billiards with it, and there was something else that it could. But as I say, it had no dynamic response whatsoever, and its zone of confusion was high. That is, it would not be able to differentiate between fingers that were perhaps that far apart. So, although it was polyphonic in the sense that it could sense more than one finger, and it's, well, I don't know, is it still not? I would think not, because the
Yeah, I think this
iPod
time.
takes
Oh,
it's a total circus.
the iPad took everything.
This is the beam. This is one of a kind, and I like it because of its shape. It's shaped like a beam. This is a lightning. There we finally see a lightning close up. So those are the wands, and the opening menu that appears on the left. Let's see. That's a Moog theremin. I forget what they call it. Ether Vox or something.
Either way.
Ether wave, that's it. That's Max Matthews, who is known as the father of computer music. He's playing here as Radio Baton, which has a lot in common with Lightning, actually, except that it's just a limited range. It only senses to 6 inches. And the software never got very sophisticated. But that was a wonderful instrument. And he did amazing things. He passed away just last month. So that's really nice. He was a close friend of mine, in fact, because he lived in San Francisco, and we had coffee every week together. That's the air drums. It was an early attempt to, and it was lightning-like also, but it didn't have absolute position. But he used accelerometers, which he made from meters, electrical meters, which he installed in the apparatus there. They could respond to kinds of movements. And he didn't dare drop them because they fall apart. The meters being fairly delicate instruments. Oh, that was more. There's been so many hundreds of controllers developed in the past few years. This one was interesting because it had discrete sensors. I forget what it's called. But it could sense position, the distance from the pole there, and also discrete sensors that were infrared based. Oh, this, you're familiar with the high controller. This is a Yamaha controller that's, I'm sure, oh, this is a close-up of the wind. So the finger positions are obvious, and there was a bit of a refined optic in the end of it, which you can't really see here, which the player playing this high, this close, didn't have to be totally nearsighted to be able to read it, because it had some projective optics, so he could recall his patches from this device. And there were switches that were located near the breadth, volume, preset, zone controls, so he could develop controls that were independent of the performance articulator. And you can see the details of the mouthpiece there. Oh, this is Neil Steiner. He did another wind instrument. I'm in the winds now. So that's his takeoff from it. And these are other wind instruments. The Yamaha WX700. They're the only ones that proliferated. This is kind of an interesting one. He sensed, in addition to looking amazing, he all exposed circuitry, but he could sense the clenching of the teeth and the pressure and all kinds of little movements and so on. It was quite nice. But I don't think he had any dreams of manufacturing it. It was a work of art. This is a guy that appears, he's from Switzerland, I think, yeah. And it's a MIDI sax, but it has no, it's made from a sax. This is probably fairly obvious, but it's not air activated. And the keying is much as a sax, it uses sax fingering. So it's kind of taking a saxophone and making a MIDI controller out of it. He did a very good job of it, and he somehow plays 4 voices with it, with different kinds of roles of harmony and so on. And oh, this is a rain stick. Rain was named after the rain stick, actually. And the original rain, let's see, I'm in Brazil where the rain stick actually, but you've probably never seen them this big. This was built in southern Mexico. I don't know exactly where. And it's built of bamboo. And the little holes that you see that you can barely see, are the periphery of where the rods are inserted around the thing. This takes about a minute to completely exhaust. You turn it upside down and you listen to it for about a minute before you have to turn it over again to listen to it some more. And there are membranes on the end opposed to solid devices. So it was the beginning of what I called the rain stick. My first version of it was a hollow lucite tube, about the same diameter as this bamboo. That's Yassi, one of my conspirators, is holding it there. And the outer tube is about this big in diameter, let's say that. And there was an inner tube about this big, not that big. And there were clear lucite rods inserted all over. And there was a detector on each rod. Now this was a theoretical instrument. It got designed but never built. But I still have the lucite tubes. So there was a microphone on each rod internally, and a multiple MIDI translator, so that it can make quite a variety of sound, but it was based on the original rain stick, so it was kind of an electrified rain stick. Later on, I designed it to sense the gestures, but not be the physical implementation of a rain stick. So I used accelerometers, which at that time were just beginning to get cheap because of the proliferation of airbags. And so they started mass producing accelerometers, and we could buy three-dimensional accelerometers that could do a fair job of sensing location, but could easily sense tilt and very easily sense shaking. So we had this gadget that's about this big, which we had to build into something. But we could build it into anything. So we could build it into a range stick, or a box, or a cube. One thing I built it into was a sphere with axes pointing out in three directions, and that could be spun as a top. So you could put it on the table, give it a spin, and it would be doing some crazy things. So by sensing the acceleration and location and so on, we sensed a lot of things. Now the analogy with the range stick is that the range stick involves thousands of particulate matter, thousands of particular particles. So its density is very high, and if you make each particle a MIDI signal, you will drown yourself very rapidly in MIDI. MIDI goes at an absurdly slow rate, and you can barely handle a keyboard, as most of you must know. But to handle a thing that can generate thousands of pieces of information per second is totally beyond MIDI. So that was not a MIDI controller. It used a language that I developed that was, they could output the gesture, which was simply acceleration and movement. And that could be MIDI. But the generator itself used new concepts of clouds and uncertainty and discontinuity or continuities of various sorts. And a whole new language was developed, and you would program it by specifying a cloud density and perhaps a pitch center or a pitch range or a just all kinds of things. You can talk about sound in very general ways of not specifying the events, but specifying clouds of events. And it could imitate, if you like imitation, almost any percussive instrument that involved lots of particles. And there are lots of such instruments, as you know, from the little beaded thing that comes from Africa. And numerous Brazilian instruments, actually, and the range stick being one obvious example. So you would specify the directions that you wanted the instrument to respond, and how you would want it to respond, and how you would form these densities of particulate matter, particulate sound, and all, okay, I won't talk about the rain, other than that it's a whole new concept of controller that has not been developed even now. I can't think of anything. I can think of an awful lot of controllers, like the little sand-filled things you do. And so, and the range stick, of course, and all kinds of versions. But none of it's been incorporated into a MIDI-like instrument. The percussive controllers in general are the last to fall. And that's partly because of that reason, is that the MIDI doesn't handle them. MIDI can't do anything with them. And the generators that we have don't respond to peculiar definitions. Any questions on that before I proceed to something else?
I would have posed.
Oh, go ahead.
Have you ever been working with haptics in order the idea that to give a tactile feedback to the performer in order to that he feels like the tension, the muscular tension that
Is everybody familiar with the science of haptics? It's the making the instrument feel like it's supposed to. So an example would be the thunder as a self-contained haptic. See, you strike this membrane, and the harder you push it, the harder it pushes back. Keyboards are very sensitive to the touch. You're actually throwing a hammer, of course, at a string, and you develop technique over the years of touching this key in such a way that it throws the hammer in a graceful way. So the linkage between the keys and the strings, which is via the hammer, is actually very, very complicated, as those of you who have taken apart keyboards know.
Excuse me,
And-
didn't Ralph Lundsten from Sweden do something like that?
Who's-
An instrument that was trying to sense your feelings, Ralph Lundsten.
Ralph?
Ralph Lundsten.
That's- I don't know that-
He's one of the pioneers in electronic music, also from the 50s, and self-proclaimed guys.
And did he use haptic feedback?
That's
It's
a
not sense.
brainwave stuff.
Oh, Hansen.
But this is, we're talking about the fact of actually producing forces in the instrument that you can feel.
Okay, I was thinking the opposite.
Oh,
How
right.
to read.
Right, yeah.
Yeah, but
No,
that was Ralph.
oh, I know Hansen. Oh, yeah, the haptic feedback has been highly investigated in the keys. People have built keys that have servo motors in them that can feel like anything you want. It could have, a key could be punched and then suddenly release. So you'll feel it going down, but its resistance will go down rather than up as you depress it. And people have built whole keyboards in these. Now these keyboards are built at incredible expense. Cost probably $100 or $200 per key, and you're very energy efficient because you have to use elaborate coils to replace the weight of the hammer in the piano, and the magnets of the coils and the electricity that it draws are stupendous. So I don't think I've done much with haptic feedback. I did in the development of Rain consider using something in the element that would give you the feeling that you were shaking something, and it might even be that you were actually shaking something. I thought this might give a good sense of playing, but I'm probably not going to do anything with it. I regard it as an interesting mechanism for the research laboratory or the research instrument, but not one for the performance instrument. It has too many drawbacks, and one of them being expense. An instrument should be available to people in some way, but also the energy efficiency.
There's an organization that I work with called NuSom that makes controllers, open source hardware controllers. And one of the projects on the table is a force feedback knob system, and these things are manufactured and they're used in military and heavy industrial applications, and they're very sophisticated and very effective. You can make a force feedback knob that gives the illusion of sweeping over any kind of textured surface. It's very interesting, but the big obstacle as yet is expense, because it costs thousands of dollars just for a single knob if we really implement this all the way. But there are simple means of having some kind of tactile feedback in an instrument, and I think a lot of the direction of controllers at the moment with the touch screen interfaces has really sort of thrown away a lot of that and made it very difficult. I find it very hard as a performer to use something like an iPad for these reasons. But obviously we've known how to make sliders and buttons and things for a long time.
Yeah, holographic, sensitive.
They're their own haptic feedback in a sense.
Holographic solution would be the best.
Well, we're interested in generating force as a result of movement of touch. How much of that is actually conditioned responses versus how much can be learned as new responses? That enters into it. But in answer to your question, I haven't done much with haptic feedback other than read about it. son Ezra. He's more into haptic feedback than I am. So, 50 Fireflies just came up. That was I've worked with many dance troupes over the years, and a dream of every one of them has been to drive the emotions into making them into some kind of a controller. Emotions of dance being extension, and height, and where you are on the stage, and how fast you're moving or running or anything. So I developed a thing which was a transmitter about an inch big, about a quarter of an inch, which could be sewn into your clothes or whatnot, or strapped to your wrist, your elbow, or your shoulder, or your head. And we know from the electronics, this being the control panel, exactly where that controller is on the stage. So we know it's like a GPS system, which we can simultaneously drive, in this case, the position of 50 controllers within a resolution of about I should say an accuracy of about, well, I'll say resolution of about an inch. The accuracy wasn't even that good because of perturbations that we got. But I never found a buyer. I mean, I never found somebody that could afford one system. Dance troupes are notoriously poor. To sell a system that would even cost $10,000 would be very difficult. So while I had 4 or 5 troupes interested, I couldn't figure out any way. We applied for grants and all kinds of things, and didn't get any government support. But it was an intriguing idea, and one that we were prepared to develop a lot of pretty exotic software to make it useful. Simply knowing the position of 50 things on the stage would not be a very useful piece of information, multiple piece of information. Anyway, let's go on to business. This was actually there's another one here. Oh, that's a shoe.
These are
That was-
FSRI.
Pardon me?
These are FSRI applications.
More or less, yeah. Most of the stuff is. But this shoe could sense acceleration and position, and it was thought of as it's on a tennis shoe because it was to be worn by athletes, so that coaches could determine efficient, not only coaches but scientists could determine efficient foot movements. And it was interesting to me because it could suffice as a controller. You could detect all kinds of movement of foot. This is it's kind of an extension of that. It's the body set that looks like a girdle. It uses electrosensors to sense ECG, as well as EKG, all over the body, and feed it to something else. Oh, this is a strange one. I saw that obviously they introduced this thing with great fanfare and lots of money. Now these things are wands. They're like the lightning rounds. It's the exception. All they're doing is sensing acceleration. I think they accelerate it. They sense it in maybe 2 dimensions, maybe just 1. So that do like this, and you can sense the velocity. And this played a note. This would be a C, and this would be a C sharp. This is a black key, and this is a white key. And so you're all familiar with gong ringers, or bell ringers. You see orchestras of people coughing up little bells. Pick up this bell, read the score. So it takes quite a few players to play. Well, this thing was developed. There's a band. There's the orchestra. They all and they're following their scores, and they all have to pick up the right one at the right instant, shake it once, and then they put it down and pick up another one. Well, in addition to being rather expensive, because each one of these is a lot, and you have to buy 40 of them. I think a system costs $20,000 for one system, and it left a little bit to be desired. In addition to sounding no more interesting than those bell ringers, it has latency built in, because there's a lot of transmission latency. The thing is scanning the central radios to decide which one is being struck, so the latency is considerable. And it was solved by taking one of the players, this guy on the right is the inventor of this thing, and he would strike his baton or wand, or whatever you call it, synchronously, or apparently synchronously with the others, but the signal would be transmitted and delayed by as much as, I think, 15 or 20 milliseconds. Pretty bad timing there. So then he would resync it, which demanded that everybody play roughly when they were supposed to play, and then everything would be resynced at the end. So he came out with perfect sounding chords, except that if you played music that didn't want perfect sounding chords, as a lot of music done, you couldn't play it because everything was automatically synced. So it had some terrible disadvantages and no advantages that I can think of. But it was such an amazing push. The guy was running double booze and big conventions and so on, coughing up his shirt at people. So this is what I would call a really bad controller, but done on an amazing scale. This is the MIDI tree.
Wow.
It is laughable. I'm going to read it. The thing I have on this one. These things consist of telescoping poles that are about 6 feet high. They look like a MIDI tree, and they have things suspended from them, and they wobble around, and they blow in the wind. And there's several of them built in one installation. So he says, I ran wires up the pole and out the branches, leaving 2 or 3 feet dangling. That's the dangling ones. The wires were bared for the last 6 inches or so, and I fashioned leaf-like switches from copper tape. As the leaves touched, MIDI notes were triggered. I covered each of the telescoping poles with fabulous black blower hose for an industrial palm tree look. So he thinks of this as industrial palm trees. I covered each of the coat hanger wires with smaller black plastic corrugated tubing, which looked very much like a smaller version of the blower hose. Synesthetics occurred a week before. That's a convention that he was apparently showing these things in. And it occurred a week before Halloween. So he finished the decorations by hanging little skulls and skeletons from it. So that's the MIDI tree. I don't think he had any design on marketing more of them, but I found it interesting. I think that's the same guy that did the giant keyboard the little kids were dancing around. I'm not sure. Oh no, that's a Jerry Hunt performance piece. I never saw it performed, so I have no idea how you work it. And that's a chainsaw. Responded to the buttons and things. I don't know the details, but I admire the chainsaw game to play these things.
It's for Freddie
Oh,
Krueger.
and that's our group playing another instrument. These juggling pins actually have lightnings built into them. You can kind of see them. And we would we weren't very good jugglers. So I was amazed to be able to get this picture with all of them here. But we actually hired professional jugglers who could do passing over a very long distance. And we had six of these lightnings, all of them on independent channels, so that we could, as you threw a pin, it would oscillate like this, or they can throw it in different ways. And so we'd get a different pattern for each pin. They were all different colors. And they could, it was the sound, rather than the jugglers kind of adhering, kind of composing their actions to the sounds, this was the sounds responding to the juggling, which turns out to be a nice concept because the opposite isn't possible. So it was an interesting way of making a controller, and we used it in several concerts when I could find good jugglers around and do passing and lightnings in front of the audience. Oh, I'm going to wrap it up with this. This is the Oricon pigeon. Now, this is a wartime device. Are any of you familiar with this pigeon? This pigeon could guide a rocket. And this was in the days, in the early days of World War II. We didn't have the sophisticated electronics that we have now, but we had the rocket. So we could deliver a rocket, but we couldn't steer it. so the Skinner, who's also the originator of, didn't realize at the time, it's been pointed out to me, he originated the Skinner box, in which you could put your baby as an infant, and his needs would be taken care of, and it would wind up, after 3 years, an idiot in a bigger box. He wasn't very successful. Then they closed down about it. The Oricon was a pretty interesting controller, and it was designed to control the direction of a rocket aimed at a city, presumably a German city. And the way that it worked was that a lens in the very front of the fuselage of this rocket would create an image of the city, of the target city, on a screen. It's a large screen, but this big. And the trained pigeon, highly trained, would, having had months of training in this box in which he was looking at precisely this photograph of the city, taken from the same angle, would be rewarded for pecking at a particular building in the city. He would get a grain of corn every time he hit the building. So he's confronted with this similar situation in which, rather than being in just a static situation in which he's attacking this building, but he always hits that one. And if they move the projection, he's trained to move it over, so that, because he always wants his corn. So they take this pigeon and hook him up inside a rocket, and he pecks at the image, precisely the building that it's been taught for several months to peck at. And if the image moves, because the rocket is off course, and so the image will move over, but he'll follow the image, and he'll peck at that same building. And a very elaborate system of valves and hydraulics and so on could pick up where he was with the peck and adjust the fins of the rocket so that it automatically returned to being right on course. The system was checked out quite a bit. They used targets in Florida, good place for testing such things, I think. And it was pretty accurate. The pigeons never freaked out. They just sat in their little rocket, and they'd get rewarded with a corn every time they made a successful peck. And so the rockets were steered to their target pretty accurately, and without the expenditure of human life that it would take to put a dwarf inside a rocket plane and just sign him off. But the pigeon got signed off. These were sacrificial pigeons. And the Foundation in the U.S. for Preventing Cruelty to Animals objected to this waste of pigeon life.
Highly trained pigeons.
Very highly trained, but it didn't take long to train these pigeons. And not only that, they could train the pigeon for several different targets, so that a rapid change in the war plans could result in a different city being bombed, but the pigeons were already there, ready for that city, and they would know exactly how to steer a rocket. But it was never deployed in the war, partly because of the animal activists. They didn't care about 50 million people being killed. But the pigeons. So there's this discrepancy. There were other problems too. The system didn't work at night, obviously. So because the visual scene was changed too much. So they never actually employed it. But I thought it a fairly interesting control. I don't have any designs or any urge to reproduce it. I'm going to so second. Oh, this is another interesting one. I'm into the animal controllers. This is a three-wheel device with servo motors on the front of it. It's about this big. And it's driven by a Macedonian cockroach who sits in a little cockpit up here. And there's a bunch of light bulbs surrounding it. Little light bulbs, 4 of them. Maybe you'll see in this picture. And when the light bulb goes on, cockroaches are afraid of the light. They want the dark. So he backs up. And a ping pong ball, at least I think that's what it was, it's been slightly modified, but it conveys his movement. Here's a close-up of a cockroach. I have an arrow, I forgot about that. And he's cemented to this bar. So when he runs, he doesn't move. But this ping pong ball rotates. So if he runs backwards because this light is going on, the ping pong ball senses that motion and conveys it to the wheels of the device. So the thing's kind of interesting. It'll wander all around the room, and every time it approaches something, the little cockroach gets scared because the light is going on, and that's some photosensors there. And the machine backs up. It goes on. I thought it was an interesting approach. There was a lot of animal rights people objected to this, but he pointed out that the glue used to cement the cockroach to the frame here was harmless and water soluble. So he did get away with it.
When you buy the device, they supply the cockroach, or have to buy it apart?
I don't think it ever was for sale. It was a master's thesis. Something, well, I'm not even sure it was used for musical purposes, but it was an interesting, I just thought it an interesting gadget. And, these are hamsters. We're still into animals. Each pair of hamsters is responsible for one sound. This is actually a MIDI controller. And he puts out and the pitch is determined by the first hamster, and the second hamster determines the loudness or I think it could be varied. Second hamster could be given a sequence or something. And the third and fourth hamster were controlling another voice, and the fifth and sixth hamster were controlling yet another voice. And they would scurry back and forth, and the music would accompany them. Called the hamster sequencer. Well, I'm gonna wrap this up with these guys here, and ask if there are any questions.
It's amazing, the inventive mind that you can show us with these instruments, but I can see that in the age of MIDI controllers, to build an instrument like that requires a lot of knowledge about electronic.
Yeah. It does
I don't
take
know.
some
I think that
resources.
today the situation is a little bit different. There are some available technologies that is it's possible to for a musician to build kind of low tech instrument with some technologies like Arduino, basic stamp. Can you talk about that? What do you think? What is your perspective about this kind of
Those approaches are terrific. I've seen amazing things done with the Arduino.
yes? What do you what would you say about Arduino? It's this library, this it's possible to a musician to make something original. This approach is, you know, I would like that you speak a little bit about that, if possible.
Well, there are several approaches to controllers. Some of them are highly imitative of conventional instruments. Some of them, like lightning, are quite a deviation from conventional instruments. And there's a lot in between. I've participated in both ends of that spectrum, building some that are basically the same configurations as their parent instruments, and building some that are totally novel and demand a whole new approach. I do think that the work that I do would involve the proliferation of the controller. I don't have a particular desire to build one of a kind. I've shown you several, but that's not my bag. I think that to be incorporated into the mainstream of music, not that that's my desire, but the controller has to be made available to a number of people. And to that end can invite a repertoire. Composers can write for it if more than one person has access to it. So I'm trying to build controllers that are reproducible and can be approached by a variety of people. I guess that's my only comment. I have a very wide range of ideas about what I could do, or what any of us could do. And I'm encouraging people to learn to do it yourself, but also the building of a controller needs to be, it's a pretty optimal device. It has to be optimized, or else it wouldn't be worth building. If it isn't optimal, then somebody can come along and improve it next year. And the year beyond that, improve it again. And pretty soon you don't have anything that can be learned, or anything that can be replicated. So in fact, that's the difficulty with a lot of software. You see software languages that are really hot stuff now, but I have languages, I have applications on this very computer that I can't open because it's 10 years old. The application I wrote 10 years ago. I can't see any of my old designs on this computer. But I can play a thunder, or I can play a lightning, I can play a theremin. They're all there.
What about affordable modular system for synthesizers?
Affordable what kind of system?
Modular system.
Motor system?
Modular
Oh,
system.
modular system.
Yeah.
I'm building a modular synthesizer now. In fact, quite a few people are. There's been a big comeback in modulars. I think software was very attractive to people for a while, and still is. But a lot of us are encountering the fact that we need more than a mouse, and a click of this button, and a click of that button to play music. We need a variety of simultaneous inputs to
How about those rehabilitation gadgets that hospitals are using, medicine is using for, say, like artificial hand? I've read something that they're doing a great job about that, taking like nervous signals for manipulating the hand, say. These are kind of controllers that goes, I don't know, directly to your nerves or something. And I've seen joysticks doing that. I've seen a helmet that you wear and you can imagine things and interact with virtual data. And I haven't seen these kinds of controllers. I don't exactly know how they work, how to
There's one that's marketed now that's it uses the muscles of that's control the movement of the eye, and actually you can actually look at something and control something. The difficulty with those controllers is the bandwidth. One of the difficulties. And then is you simply have very, very low bandwidth. In the order of a few cycles per second at best. Whereas fingers on the piano do 1,000 times that much. So, while it's nice to think about music, getting it out of the head or of the body and so on is difficult. It's an expensive proposition. Another problem would be the wiring of it. People don't seem to like to have electrodes put on their head and arms and belly and everything to play their music. And I feel the same way. I don't like having to get into it, to even put on a glove to play the music. I mean, pick something up and play it and be done with it. Just a personal opinion. So, and I've tried. I did a rendition of David Rosenboom's brainwave music in Copenhagen. And I had a great difficulty in rehearsal. It went fine, but on the stage I had trouble generating enough alpha rhythm to create the first sound. So 15 minutes went by with the audience, total silence, and me sitting on stage trying to get the alpha going. Well, it wouldn't go. And it's kind of like, it's uncertain, this kind of thing. I had to finally cheat. An escape hatch. But so the bandwidth, the difficulty of developing the control mechanism, those are contributors to the fact that we don't have direct connections to the source, as we say. We depend on our muscular apparatus to get out of the brain into the physical world. But there are bigger problems than that, or at least one we keep touching is the software. And it's gotten to the point where we can, as Ezra pointed out, we can sense just about anything we want in the body. It's pretty easy. But translating it into a meaningful musical gesture takes some software, it takes some doing, it takes some thought. It takes a lot of money. Because programmers are highly paid in our society. And it takes a lot of training, because you don't learn the software overnight. The Arduino computers and the proliferation of simple software partially solves the problem, but not entirely. So learn to be programmers, you all. If you want to build instruments, you're going to have to deal with programming. Are there other areas? If you want, I could play you a DVD of a recent concert we did. Short version. I'm not
Sounds
hearing
like-
anything.
Where'd it go?
Oh, it might be
The,
oh, there it is. I can hear it.
it's coming from
It's just a,
you go to the control panel. No, that should come from this interface. So
Yeah.
seeing the shape of the city's
got the preference.
Preferences system.
Go back to the
Yeah, you have to.
application. Oh, you have to click on the application.
Yeah, okay.
Yes, come on. Just go here.
Okay.
This is the one I was telling you about with the lightning. Does everybody know what Fajnak is? Does no one know? It's similar to the, occurs at the same time, in fact, as the carnival in Rio, except that it occurs in Zurich, Switzerland. I went to, in it, the people who are preparing, as they do in Rio, all year round, for Fajnak. They douse the city lights while they drive in the dark. In fact, you can't drive. They don't allow cars into the city for 3 days. And they all light up big lanterns and they put them on their heads. You'll see some of them a little later. They go completely berserk, but the musicians are playing. They travel around in troops, and they're half playing the drums, and the other half are playing fifes, flutes. First time I went, I was intrigued by the music, by hearing as many as 40 or 50 groups independently moving around the city, kind of trying to interfere with each other, so that they would steal each other's melodies. And so this is what I went back to where I was doing a residency, and I wanted to do a piece based on Fajnak, but I couldn't, and I was in Amsterdam at the Stein, and I couldn't find enough flute players or enough drummers to come up with anywhere near enough players. So I decided to do it all on a synth, and that's what I did, and I got flute players to play loaves of bread, and drummers to beat German loaves of bread. These were baguettes for flute players, and to play them with Italian breadsticks. So there was, the only sound was the occasional crunching of breadsticks and so on. And it worked out well. I did all the music was performed on a thunder, which is that green instrument that was on the stage. But I just redid it for the 200 year. And there's quite a complexity of overlapping and intersecting rhythms. And we used costumed walkers that were derivatives of the original walkers in the Fajnak. Cloaks and things, and little electric cameras on their heads. These are photographs that I took in Fajnak in the background. You can see the walkers with the cameras on their heads, and they're all playing their breads. Fight, I guess. see, how do we get back to the big picture? Oh, the space bar there?
I think you stopped it.
Oh, I stopped it,
And
yeah.
then you came back to the
Yeah.
main menu.
I didn't know how to start. No, that part-
There's a button menu there, down there,
Which, where is it?
on the main interface, yes.
Yeah. I wanna get to the large view. That's what I'm trying to do.
Press play and then command F.
Right?
There's the third button, upper part.
Oh, it's good to have a skilled programmer. Oh, no, yeah, here we go. This is another piece. Strange.
Muito bom.